What is up, everybody? So I know that geometry is a sore spot for so many students, so these are 10 questions you absolutely have to have down for the PSAT, SAT, and ACT geometry, okay? Let's do it. All right, here we go. So for this one, what we got to do is we got to work with special right triangles. I found these extremely annoying when I was in school because the way that I was taught them made them overly complicated. And what we're going to do now is break it down so it's a lot easier to deal with. So here we have, if the diagonal of a square is 8, what is its area? Let's just start with the fact that it's a square and let's draw that out. So let's draw our square. Now, what are we going to do? We're going to draw a diagonal. And this is what a diagonal looks like in a square. And we know that that length is 8. Now, how are we going to find out the area of the square? What we're dealing with here is a special right triangle. And the cool thing is, because it can seem a little overwhelming, there's only 2 special right triangles that you need to worry about for the SAT and the ACT. Now, the thing is that on the SAT, these are actually printed for you at the beginning of the section, which is great. For the ACT, they're not. Either way, the most important thing is that you know how to work with them. So here's what's going to happen. First of all, each angle in a square is what? 90 degrees, right? So each of these angles is 90. And when you draw a diagonal in a square, you cut that 90-degree angle exactly in half. Instead of 90, for these angles, it's 90 divided by 2, which makes each of these 45. Now, what happens? What happens when you have 2 angles that are the same in any figure? The sides opposite those angles are equal. So here, across from the 45 and across from the 45, those are both the same, and we can label them both x. So we have x and we have x. And we know the hypotenuse here is 8, the one opposite 90. One key step here. You could get this right at this point by doing Pythagorean theorem, because your a and your b would be the same. So you could say x squared plus x squared equals 8 squared, and you could solve it that way. The thing is that you need to know the 45, 45, 90. So we're going over that right now. With a 45, 45, 90, the ratio is x, x, x rad 2. Now, that means the x rad 2 side is equal to 8. Now, before we actually solve this, here's the deal. We're going to get into some work with radicals. We got to be a little bit careful with this, and we need to know our rules with radicals. If this is an area that's a little shaky for you, what you want to do is slow it down, pause it, make sure you understand each step, and then watch it again if necessary while you're actually working out the practice problems. So here's what's going to happen. X rad 2 is equal to 8. Let's start by solving for x. And remember, why are we doing this? What's the goal here? We want the area of the square. And what's the formula for the area of a square? It's side squared. Area equals side squared. In this figure, the sides are both x, right? So we need to solve for x, and that's what we're doing here. So we have x rad 2 is 8. We divide both sides by rad 2. The rad 2's cancel on the left, and on the right we have 8 over rad 2. Okay, that's pretty straightforward. Now remember, you can only simplify numbers with numbers and radicals with radicals. So 8 over rad 2, the way it is right now, cannot be simplified, and the other issue is that you technically can't have radicals in the bottom of a fraction. So what are we going to do here? We're going to get rid of that radical. So what we're going to do here is we're going to multiply the top and the bottom both by rad 2. Remember, you can multiply a fraction by anything so long as you do it to the top and the bottom. When you're doing this to something with a radical in the denominator, it's called rationalizing. So here's what we're going to do. We have rad 2 on the top, rad 2 on the bottom. Now let's multiply. 8 times rad 2 is just 8 rad 2, because remember, there's nothing you can do to combine numbers with radicals. On the bottom, rad 2 times rad 2, keep the radical, you get radical 4, because it's within a radical to start. And radical 4 is just the square root of 4, which is just what? 2. So now you have 8 radical 2 over 2. Now you can simplify the 8 and the 2 because those are both just numbers. And what do you have? 4 radical 2 is the side. That is x. Now remember, we're trying to find the area of the square. That's our goal here. Area of the square is area equals side squared. We know our side is x, which was what? 4 radical 2. So we do 4 radical 2 squared because area is side squared. And what do we need to do? Square both 4 and radical 2. 4 squared is 16. Radical 2 squared, whenever you square something that's within a radical, all that means is get rid of the radical. So instead of rad 2, you have rad 2 squared, which just becomes 2. 16 times 2 is 32. Answer choice E. Alright guys, thank you so much for hanging out with me. Make sure to watch the rest of the videos in this series to get the help that you need for the PSAT, SAT, and ACT. And make sure to check out our other series. And if you haven't already, like and subscribe, because this is obviously the best thing that's ever happened to SAT prep. There we go. And I love it. I think that's the one.